So today we are going to start with a new topic of artificial intelligence like machine learning. Machine learning is a topic which come under the category of artificial intelligence, or it can be a separate course, or it can be a separate learning module which can be used in a different area. So machine learning can be treated as a different the topic or different area for learning itself or studying itself or researching itself, but majorly it's a part of artificial intelligence. So let's start with it. I hope you all enjoy along with me, because it's very important. All the robotic industries are working on the basis of machines learning. So I hope you will enjoy my lectures and notes a lot, and let's go along with it. Okay, here we start with machine learning. Overview of what I'm going to cover is non-symbolic machine learning concept, neural networks, unsupervised learning, k-nearest neighbor learning, use of a knowledge in learning, analogical reasoning for learning, reinforcement learning, genetic learning, and theory of learning. Non-symbolic learning. Non-symbolic machine learning approaches. It relies on the weight optimization or gradient descent search. Instead of symbolic generalization and spatialization in learning, for example, neural network uses a gradient descent search, or it relies on adaptation to environment through fitness function. For example, evolutionary learning such as genetic learning uses this approach. Now we have the actual and artificial neuron. So if you see the diagram of the actual neuron and how we have converted that actual neuron into the mathematical diagram that is called as artificial neuron. So if you see the actual neuron, it has the input is given through axon. Each input body part has cell body, and then through axon the input signal is given and output is generated through output signals like terminal branches. So that is converted into the artificial neuron. So that consists of input signals, that is xi starting from x1 to xn. This data may come from the environment or the activation of other neurons. Different models vary in the allowable range of the input values. Typically inputs are in the set like 0 1 or -1 1 or real numbers. Next we have a set of a real value weight starting from w1 to wn, that is nothing but wi. So the weights are used to describe the connection strengths, and as we see shortly, the strengths of bias links. And the activation link, the activation level, summation of wi xi. So that triangular shape we see is nothing but your activation level, which does the activation like summation of wi xi. Wi xi is nothing but the multiplication of w into x. So neurons activation level, so the neurons activation level is determined by the cumulative strength of its input signal, where each input signal is scaled by the connection weight along with the input line. Activation level is thus computed by taking the sum of a scale inputs, that is wi into xi. So we have to multiply x1 with w1, x2 with w2, x3 with w3, so on till xn with wn, and add all the values, that is nothing but summation of wi into xi. Then we have a threshold function, that is nothing but f or activation function, which computes the neuron's final or output state by determining how far the neuron's activation level is below or above the threshold value, and it is calculated by the function summation f of x and threshold value. Threshold function is intended to produce on and off state of the actual neurons. In addition to these properties of the individual neurons, a neural network is also characterized by global properties such as the network topology, A topology of a network is the pattern of connections between the individual neurons. This topology is a primary source of a net's inductive bias. The learning algorithm use. A number of algorithms are presented in this chapter. An encoding scheme. It includes the interpretation placed on the data to the network and resulting its procedures. Now, McCulloch-Pitts neuron model to calculate the logic functions and or. It is established in 1943. Look at the diagram. First diagram represents and next diagram represents or. So figure shows McCulloch-Pitts neuron for computing a logical function. A neuron has three inputs. If you see the first and second diagram, neuron has three inputs. X, Y are the values to be conjoined, and third sometimes call it as a bias. So X and Y is values to be conjoined, and third sometimes call it as a bias. It has a constant value of +1. So bias has a constant value +1. The input data and the bias has the weight of +1, +1 and -2 in case of AND. Thus, for any values x, y and the neuron computes the value of x plus y minus 2. If this value is less than 0, then it returns a -1. Otherwise, it returns a +1. So if you look at here, look at the AND. X, Y are the data inputs and this is the bias value. +1, +1 are the weights of the X and Y, -2 are the weights of the bias value. So for any value X and Y, neuron computes the value X plus Y minus 2. If this value is less than 0, then it returns the -1. And if otherwise it returns a +1. So if you look at the truth table, -1, -1 and -2 are the entries of the truth table where the output is -1. And if you look at the first row of the truth table, output is 1 because the X plus Y plus -2 output is 0. If you look at the table, you will have the idea. The weighted sum of the input data for the neuron is greater than or equal to 0 unless X and Y equal to -1. Now look at for the OR gate. Similarly, for the OR symbol, X, Y are the data input, 1 is the bias. +1, +1 are the weight for the X and Y, -1 are the weight for the bias value. And the function value is calculated as X plus Y minus 1 because these are the weight which is to be multiplied with X. So X plus Y minus 1. So this is nothing but the OR value. So if you calculate the value of X plus Y minus 1 with respect to the X and Y input, if the value of this is going less than 0, then the output is -1. If it is more than 0 or more than 0, then output is. Next we have a perceptions learning.